This lab here, we're going to look at local system exploitation. This is going to be the idea that we have our target close to us, near us. It's a facility that we can actually gain access to. So in this scenario, maybe we just walked in, we found a workstation that's unoccupied and it's just sitting there. So what we're going to attempt to do is we're going to use a Kali Live disk. We're going to boot off of that. We're going to gain access to the SAM database, and we're going to try to extract the account passwords off there. Now, that could be just local system accounts sitting right there. That could be the administrator account that might be replicated across multiple systems. So this could prove to be extremely valuable to have. In order to do this, what we're going to want to do is have access to the Kali Linux ISO. We will take this ISO and force the VMware system, if it ain't broke, to boot off of it. Once it boots off of it, we would then be able to use this in a live based environment. Let's begin our search now. So Kali Linux download. Through your Google search, you hit enter and you should be able to go right here to kali.org downloads. You'll see at this current time it's version 108. What we're going to do is an ISO download, a direct download. You're going to see it's pulling down, and it is 2.9 gigs in size. The ISO itself is an image of the DVD media that has the Kali distro on it. Let me explain a live disk to you. Basically what we're doing here is using the ISO to boot off of, jump into a live environment, meaning we are going to use the media that's going to house all of the operating system files for the Linux distro. The system's RAM, the hardware, the RAM that the system has available to it, that's what's going to be used during our code execution. We're not writing anything permanent back to the ISO. You can't write to that once it's established and created, and we're not writing anything permanent to the system hard drive. So we're doing this in an environment that we should be leaving no traces behind unless someone was able to confiscate the system while it was powered on and they could extract data out of that RAM. As we know, once the system powers off, that RAM will begin to dissipate and lose information rather rapidly. So this process should be something where we walk in, we gain access to a system, we use a live disk, we extract what we need, and we leave no traces behind. We'll see how it works. I'm going to pause while this finishes downloading and we'll resume here shortly. So my system is finished downloading. Here we have Kali Linux 108 64-bit. This is the ISO file of it. So from there, I'm actually going to take VMware Player and I'm just going to start the basic player up without actually executing any VM system yet. The purpose for that is, if it ain't broke is the one we're going to have interest in, but we're going to edit virtual machines. We will ask that the system is going to connect this drive at power up. We're going to use an ISO. So we're going to say, hey, I want you to boot off of this ISO at power up. It's going to get a little tricky here as we attempt to start this system. Here's what's going to happen. I'm going to let it run a couple times and explain to you what we're doing here. When we power on this virtual machine, we're going to get a boot option that's going to display so that we can change the boot order. The catch is that VMware Player displays this extremely quick on the screen. So we need to know what key we have to press in order to get into our boot menu, and two, we're going to have to power on the virtual machine, hit that key extremely quick. Remember that you're not sending commands to this system until you actually click in the window as it's booting up. So power on, click in the window, hit your key, which is going to cause us to get to a boot menu. Let's go ahead and give it a shot here. I'm going to power on, and the key that we have to press is the escape key. So here we go. I missed it. Once we get here to this window, we didn't catch it in time. So let's get out of here and let's restart the guest. I'm going to hit OK for a restart. Let's see if we can send a Control-Alt-Delete here. Alright, there we go. This is the menu we're going to want to end up at. This is a Control-Alt-Delete to the virtual machine, which will cause the system to reboot. So you're going to click that, click in your window, then hit the escape key. If you miss it, click the Control-Alt-Delete, click in the window, then click your escape key. This is where you're going to end up. Once we have access to this menu, you're going to press down a CD-ROM, you're going to hit enter, and we're going to boot off of an ISO. We want a live AMD 64 start. I'm going to hit enter. Now if you remember, this is our if it ain't broke system, our Windows based system, but we're actually executing Linux right now. Give it a few minutes and let it start up. You do not need to log in. It's going to take you right to a desktop environment, and from here we can begin doing what it is that we came to do. We're going to grab this SAM database, we're going to use John the Ripper, and we're going to try to pull the passwords from here. Alright, so once here we're going to type in fdisk dash lowercase l, that's for list. We want to list all the drives that we have available to us, and we see that we have a dev SATA 1. That's actually going to be our OS for the Windows system. As you can see, there's our NTFS partition. Locating the drive that we want to use, we now have to actually mount the drive. So we'll use a mount -t, T being type. What type of drive file system are we mounting? It's going to be an NTFS drive. Which drive do we want to mount? We want to mount the SATA 1, and we're going to place this mounted drive into the mount directory. Probably a good idea at this point to confirm that the disk actually mounted for us. So we'll do a df-k, and we will see that we have a SATA 1 listed down here at the bottom, 42% used, and it is located in the mount directory. So let's go ahead and change that to directory so we can have access to it. Let's do an ls, and you will see that we are actually now looking at the Windows hard drive. There's our Windows directory right here. To get access to the SAM database, we need to go to the Windows System 32 config directory. So let's, from this point, we're going to choose Windows. Go ahead and hit enter just so you can do it stage by stage and make sure that you're getting where you need to go. Make sure that you're typing in all caps where it is all caps. It is case sensitive. System 32. Let's choose one more time for the config directory. We should be able to do an ls, and we're going to see our files that we want. Here's the SAM database. Now the passwords that are stored in the database, they're just hashed values of the password. So what we will need to do is we're going to have to dump the sys key, and we're going to have to dump the password hashes. That way we can interrogate the database and pull the passwords from it. To do so, there's a tool called bkhive. That's what we're going to use to actually dump the sys boot key from the Windows system, which we will be using here in a minute. Type in bkhive system/root/hive.txt. Now what we've done is we're telling bkhive to grab this system file, extract the sys key from it, and place it here inside our root directory in a file called hive.txt. It says that it was able to do so. We have a boot key available to us to use, and so far so good. The next thing that we're going to want to do is we will need to dump the Windows user password hashes. We'll use the sys key against the hashes. We should be able to pull out some passwords potentially. So let's see what we got. SAM dump 2. Got a typo there. SAM dump 2. We're actually going to do this against the SAM file. We have to reference where our sys key is located at, which is the hive.txt file, and where do we want to output any extraction of password hashes. We'll dump them into a file called hash.txt. Looks good. Looks like we're ready to continue on. Now keep in mind, at this point in time we have placed the sys key and the password hashes in our Kali root directory. that root directory where all of this stuff is being placed at, this is all occurring right now in the system's RAM. This is not being written to any actual directory that can be accessed once this system is powered off. First thing that we're going to want to do is let's move to that root directory and confirm that we do have what we came for. So we change back to our root directory. I'm going to do an ls, and you see that we have the hash file and the hive file. A couple of things we can do here. We can perform an ls, l, anything that's a text file. So we'll do star.txt. Now we do see them there. I'm just showing you a couple other things that you can do just to narrow down your results. And we see what we actually have here. Some size potentially behind it, so we know that there are some data within these two files, and we can actually confirm what some of that data looks like by doing a file star.txt, and the hash.txt, that's an ASCII text document, and the hive.txt is a non-ISO extended ASCII text. No line terminators. We have what we need. This is correct. At this point, let's go ahead and view the contents of the hash.txt file using the cat command. Cat hash.txt, hit enter. I can't spell. Come back, place an A, and you'll see here we actually have the administrator information, we have guest information, help assistant, support, an account called delete, it's kind of weird, XP student, Lazy Larry, Simple Simon. It looks like we have our two administrators here as well, who are probably the ones setting up all these workstations and not doing such a good job. At this point in time, we can get the passwords actually extracted by using John the Ripper to crack the password. So basically what's going to happen is John will attempt to crack each user account that we specify, as long as they're contained within that hash.txt file. Now, your deliverable, what you're going to want for this lab, is Lazy Larry, Simple Simon, and the administrator account. So right here from our root directory, what we're going to do is type in John so that we can invoke the command to actually start the John the Ripper application. We're going to tell John that we want to look at root hash.txt. That's the file of interest right here in the directory for where it's located at. We do need to explain the format that this data is stored in, which is NT2, and we also need to specify a user account of interest here, which will be the administrator account. Let's go ahead and hit enter, and it now tells you it created a directory under the root called .john. It loaded one password hash. It has come back and determined what the password is, and as you can see, this guy's blank. Guesses one time, and at this point in time we have cracked one of the accounts. Now again, for this actual deliverable here, you're going to want 3 different accounts. And now let me show you a little trick here. One of your other accounts that you're going to want to crack, as we look up here, Lazy Larry and Simple Simon, they have spaces in them. To specify a username with a space, you're going to have to place that entire name inside quotes. Hit enter, and it will come back with your password. You're going to want to repeat that process for Lazy Larry as well. To actually display all of the passwords that we were able to crack, you want to browse this directory right here, cd space /root /john. That's a directory that was created by John the Ripper. Inside there, if you do an ls command, you will notice that there's a john.pot and a john.log. The john.pot is the one that's actually going to contain the file. So if we cat john.pot, you'll see that here's the hash associated to a user, here's the password, here's another associated to a user, here's a password, here's another associated to a user, and here's the password. That's going to get you through this lab and everything that you need to do. Remember, you're going to need to take a screen capture. I need your date up here for when you perform these actions. I need you to show me the passwords that you were able to capture by viewing this directory here, and that's what I will use for your grading. At this point in time, we would be able to come back here. We can shut this down. A couple things: if we're in a hurry to get out of there, just eject the disk, or you can do it politely and power off, or you can come up here and go to power and tell it to shut down the guest. At that point, once the system shuts down and you have your disk in your hand, you're out the door and you're good to go. You have the administrator accounts and you're done. I'll see you in our next lab.